I want to welcome everybody to today's lecture, and we'll be discussing optimizing deep learning training. And under that, we'll emphasize on transfer learning. So today our focus is on transfer learning. Let me proceed. I want to tell you that we won't waste much time today. It will be more of hands-on than the theoretical part. So first of all, we want to know what we mean by transfer learning. Transfer learning is a process where you have your own new data and there is an existing pre-trained model which you can use your new data to be trained using that existing pre-trained model. So in a simple term, we can say it's a process of using learned features from already trained model. So that is the process of what transfer learning. And how do you do that? You do that by using the weights and the upper parameter of the pre-trained model to achieve that purpose. Uh, then, in order to get good uh, result or desirable accuracy, so what you do is to also tune further the upper parameter of the already trained model, which we refer to as a pre-trained model. So this gives you the ability not to start building your network layer from the beginning, your deep neural network rather. That is, you're thinking of, okay, how many convolutional layer do I need to have? How many pooling layer do I need to have? You don't need to bother about that again because there is an existing pre-trained model which you now bring your new data and you supply into that existing pre-trained model, which will give birth to the new model with your new data. So why transfer learning? Why do we need to use transfer learning? One of the main reasons is that you don't need to build your model from the scratch again. Because this is very important. Nowadays, where there are complex tasks to solve, and those complex tasks require large models to be built. So, and for you to start from the beginning is a lot of labor and a lot of brainstorming. So, since there are large deep neural network existing, which are robust, they are state of the art. So we can leverage on those existing deep neural network by bringing our own new data and using that existing network, deep neural network to train our own data, and we can harvest our results. So one of the major advantages you get is that it requires less data to train. You only need to use lesser data based on the complexity of the task you want to achieve. And why do you need that? Why do you need to use less data? Is because the already trained model has been trained with large data before. So the model is has the ability to recognize variation in data, and it has the ability to learn those features. So it already knows those features already. So when you want to train your own new data, you don't need large data which match the complexity of the task you want to train. So you only need just a handful of data. When I mean handful of data, I'm not saying so small data, but a sufficient data to a level where you will use to train. So it requires less data than the usual one. Then also you have the time of training of your data it will be reduced. That is, you have speedy training time, because why? Some of the things that your data is supposed to, your model is supposed to learn, if you are building it from the scratch, the already pre-trained model already have those features, already know how to extract those features. So it doesn't need to take long for it to extract those features. So it learn faster. And lastly is that it saves costs. So especially if we look at it from the domain of uh, computer vision, we can see computer vision, one of the main challenges there is data. Data is scarce, data is expensive based on the task you want to perform. So if we look at the health domain, data there is also scarce. So when you have a pre-trained model which already has those capacity, it's been trained with large data before, so you don't need to use much data. So it saves you cost of what buying data that you require to train your model. We'll look at existing AI domain for transfer learning. What are the domains where we can use transfer learning in AI? We have the image classification, the transfer learning model, which exists for that. Also, object detection. There's transfer learning, which also exists, model exists in that also. Then segmentation, image segmentation, transfer learning also exists there. So those three is classified under computer vision. And then there is the automatic speech recognition. There's also a model for that. And also the NLP, natural language processing. So these two also, they classify under conversational AI. This domain, they have transfer learning model. Transfer learning is possible in this domain. We will talk about transfer learning with NVIDIA TAO. This is a framework or stack which we can use as for achieving transfer learning. And TAO means train, adapt, optimize. So you can get your pre-trained model from NGC. I will show you. I will talk about MGC as we move further. And you will also have your custom data. This is your custom data. So once you pull your pre-trained model from the NGC, uh, from the NGC, sorry, let me see if I can get this. Okay. You pull your pre-trained model from the NGC, everything goes into TAO. Inside TAO, you can do data preparation and augmentation. You can train inside the toolkit, and then you prune. After you prune, then you have your customized AI model. So all of this will run under CUDA X using your container, and then the CUDA is there, cuDNN for the training. Then when you want to inference, you can proceed further to optimize using what we call Tensor RT. And the training can be done on your workstation, on DGS, on the cloud. You can reference inferences on this platform as well. So for more information on this, you can visit this link. So what are the pre-trained models that exist on NVIDIA TAO? We have two types of pre-trained model that exist there. We have the one called purpose-built pre-trained model. Now, this pre-trained model, they are built for you to use on the go. You may not even need to supply your neural data. They are just built for a particular purpose. Example is the people's net. This model recognize persons. There is also the 2D pose estimation. It recognizes human pose estimation. There is the license plate detection, license plate recognition. All of these exist. Also, it does exist in the NLP domain as well, where you have the BATs, you have Megatron, and the likes there. And the second one is the general purpose model. That is, this general purpose model, you can bring in your own data, your new data for your own specific tasks. You can use those model to achieve that purpose. And under that, we have three categories, which are image classification, object detection, and segmentation. So for under image classification, you have the efficient net, which is there, very popular. There is the rest net, 10, 18, 34, 50, and 101 layers. There is the VGG 16 and 19, the dark net, which was used for YOLO, the mobile net, Google net, and the likes. They are there as well. So for object detection, there's the YOLO V4, YOLO V3, fast RCNN, And for segmentation, you have the max RCNN and UNet. So you can pick this pre-trained model and take your new data and supply into this pre-trained model and train using that pre-trained model to train your data. Then you can now have your new model and make use of it. So example is what you can see here. I will play this. You can see. So this is, you can see it's recognizing the plate number, that is a car. It's showing you how many vehicles are on the screen. There's 0%, this plate number, and it can also recognize what the number on the plate number as well. So these are general purpose. I mean, these are specific purpose model which you can use specifically for license plate. Probably somebody who is working on a toll gate, so this can be used deployed for a toll gate use. There is also what we call the image posts estimation. So this one, they can use it for action recognition. Actual recognition, that what is that person doing? Is it dancing? Is it the person, is it jumping, or is it picking something there? So they can use this as well for that. And there is the people's net, which I talked about as well. So it recognizes woman, that is a person, and it's counting them as well. Then we also have what we call the face max estimation as well. So it can grab your face. It's like a focus, where if you turn to the other side or any side, it can get the features of your face there. So there are many of them that exist. They're also in the conversational AI domain as well. There are many pre-trained model which you can see with NVIDIA TAO. There's also text-to-speech, natural language. Under that, you can see these models are already there, BAT for test classification, punctuation, and the likes. There are so many of them that does exist. So we're back here. So let me talk about the overview of the TAO toolkit with respect to computer vision. So what happened is that you have your data here, your raw data. So you need to process the data, convert it to a particular format if you want to use transfer learning. So using transfer learning, you need a pre-trained model. And for you to be able to use a pre-trained model, you must have full details, the know-how of the pre-trained model, what kind of data, what is the dimension of data it can accept, what is the format of the data it can accept. So you do that here, you convert your data, augment your data, and everything goes into train. And where does it train? You bring in your pre-trained model as well. So then you train using the pre-trained model. So when you train, you evaluate your training results. If it is bad, you have to go back and train. And then if it is good, you proceed to prune. Now, pruning is a level of optimization such that it reduces the size of your model. And when it reduces the size of your model during inferencing, your model will be faster. That's the purpose of that. It will be faster, but there is a detriment to that in the sense that because it's pruned your model, the accuracy is bent to drop a little bit. So what happened is that after you prune, it is advisable to retrain again so that you can get back your accuracy while you have the benefit of small size model with faster inferencing. So you retrain. After you retrain, you evaluate the training. If the result you're getting is not good as before you prune, you go back again and retrain. If the result is okay, is good, then you can export your model and use it forever, or whatever you want to use. And along the line, you can also do what we call int8 calibration, which is also a form of optimization to make your model also run faster. So this is all what I've explained. I've showed you before about those AI model that are ready you can use. Now, transfer learning I just want to show you some examples of those model which we use in transfer learning. For image classification, there's what we call the VGG16, and there's also VGG19. So this model is good for feature extraction. So they usually use it in other big models as well. You can see it can serve as a backbone for some other models. The essence is that if you are dealing with a task that need feature extraction, so this is good to help you extract features. There is also the ResNet. This is a model. This consists of 50 layers. The ResNet 50. We have ResNet 50. We have ResNet 18. We have ResNet 34. So this is example ResNet 50. It makes use of skip connections. That's what it makes use of. Skips connections, and it performs better in terms of feature extraction than VVG 16. So you can also look this up, because this is important, because before you can use this type of model, you need to understand the flow, how the data format, like I've explained before, and how the model works internally. So our application focus for today, so as not to waste time, will be NVIDIA TAO Toolkit. There's also YOLO v4, there's YOLO v5. We don't know if there's not, we might not be able to cover YOLO v4, but I will try as much as possible to also to cover YOLO v5. But with the YOLO v5, we want to cover computer vision here. Now with NVIDIA TAO Toolkit, we want to cover image classification. So with this object for YOLO v5 for computer vision for object detection, because we might not be able to use camera direct because I'm using SSH. Let's see how it goes, but we'll find a way around that one. So let's proceed. Now, overview of TAO image classification phase. So if you want to use NVIDIA TAO for your transfer learning to achieve image classification tags, the first thing you need to do is to check your input data structure. So what I mean by this is your data format, rather. That okay, you must have a particular pre-trained model in mind you want to use. Let's say, for example, ResNet. So you must know, okay, now the data, my raw data that I want to use, it must be in a particular format which ResNet which can serve as input into ResNet model. So you consider that. After that, there's what we call the specs file, that is the configuration file. That configuration file is for the pre-trained model. You have to configure it to suit your new data your new data that you are working on. You have to configure it to suit that. So there are phases in that. I will explain into details as we proceed. Then after you've configured your specification file, then you start training your model. After training your model, you can proceed to evaluate the model. And when you evaluate the model, you can prune the model, which I've explained before. So while you prune the model, the size is reduced, then you need to retrain if there's an accuracy loss while you prune the model. You retrain and test. When you retrain and test, you check the accuracy. If the accuracy is not satisfactory, you keep retraining. And when it is satisfactory, you proceed to inferencing. So you run your inference, and when the inference is good, you can now export your model and use it for what you tend to use it for. So let's consider the case of ResNet 18, that we want to use ResNet 18 format. So ResNet 18, so how do you do that now? First of all, you prepare your data set. Let's say this is our data set. We have it already. And we've splitted it into test, train, and validation. They're all inside our images. So we want to do image classification. So in each of these folder where you have test, what you will have inside is the folder consisting of the image and the class. So the image will be inside for example, for boss, all what will be here were images of boss. Then you name the folder with the name of the class. So each folder here consists of distinct images, not mixture, distinct images. So for example, if we take image of a person, for example, what we see there is just persons like this. So what is inside each of these? For aeroplane, the image that will be there will just be aeroplane. For bicycle, the images that will be there will just be bicycle and all that. Then if you now want to go further to do maybe for computer vision, then your data set has to be in this format, Kitty format or TF record format. But we're just doing, we'll be dealing with just image classification. So data will just look exactly this way, which is just JPG, and we arrange them in terms of their classes in folder, and we have the version of test, train, and validation. So the specification file, the specs, there's a folder called spec. So that spec, that folder of spec consists of two files. There is the classification spec and also classification retrain spec. So when you want to train, you will use the word the classification spec. To train, you configure that one to training. So after you've trained and when you intend to prune, after your pruning, you want to retrain, then you use this one classification retrain spec is what you will use. Now for each of these, they are divided into, there are three segments inside of each of these. So the first segment is the model configuration, train configuration, and evaluation configuration that are there. So I will show you the internal structure now. So this is the classification spec.cfg file. So this file, what happens here is used for training. So inside it, you have the model config, you have the train config, and you have the evaluation config. So for the model config, you specify the architecture you want to use, which is what we've specified that it is ResNet we want to use. Pretrained model, our pretrained model will be ResNet of what type? 18 layers we want to use. So the image, okay, what is the input size? So the input size for ResNet will be, the dimension will be what you see here, 3 by 224 by 224. Then we proceed to the configuration, the train configuration. So where will you get access to your train data set? So this is train underscore dataset path. So you have to specify the path where your data is, and also your validation data path. This is val underscore dataset path where it is, and then your pre-trained model, the model you want to use to train this, which is our ResNet, you specify the path as well. So it is saved as what? ResNet underscore 18.hdf5. Then you look at it, okay, the batch size by GPU, then the number of epoch, which is what, 80, you set that. Then the learning rates, also you set that. Then when you, for the evaluation also, the part of your data set, your evaluation data set, that is the test data. So you set the part as well, like what you are seeing here. Then the model part, that is after you finish training, where it save it so that it can use it for the evaluation, you set the path as well, because the model will be saved in output. So you set the path as well and all that. So there are details about all other features here, but I'm just telling you the default ones. Which then this is now the classification retrain specification file. So it's similar to the classification specification file, that is the one we use for training. So the only difference that you have there is the pre-trained model part. That is when you pre-train, when your model has been trained and when it has been pruned. So where are you going to get the model to be retrained? So you specify the path this way. It's also there. I will show you the folder structure so that you don't get confused. Also, when you want to evaluate as well, this is the path. So you set all these paths. These are paths that are on your systems. So it's not compulsory that it must be what you are seeing here. Exactly. So it's based on your the folder structure on your personal laptop or workstation that you have. So quickly, let's jump into a demo for that so that we know what we can do about that. So what I will do now is I have to connect to my workstation. Sorry. Okay, SSH to my workstation. Okay, good. I'm connected now. So the next thing to do is to so before you can use the NVIDIA TAO for your transfer learning, you need to pull the container So let me show you where you can pull the container here. So you come to this place. This is catalog.ngc, like I showed in the last image, nvidia.com. So when you get here, so what you do is you click, you search. You can search, just type TAO, and when you type on TAO, you can see this is if you can see what is here. This is TAO toolkit for CV. CV means computer vision. So there's another TAO here for conversational AI, if that is what you want to deal with. So what we'll be dealing with here is this. So we go, then these are details there you can read about it, and you see what it can do. So, and these are the list of all the models that are inside the TAO. We should see up there. So you come to this place, you click on this tag, it will come down. So you select one of them. So if I select this, you can see its command is pull to clipboard. So you can now go back to and you can come here and say Docker pull this. I've already pulled this already. I've done that. So once you pull this container, then the next thing to do is to run the container. You run the container, so you don't need to cram anything here. Everything is explanatory. Let me see. You can just you store them somewhere so that you don't, because they're very long, I must say. So I will explain this part to you. We'll explain the parts. Come English. So I come here, then I paste it here. Let me expand this, what I have here. So what you can see here is that okay. So this is sudo docker. You can run the GPU all. This is use all the GPU that are available, then make it in interactive mode. You remove it when you are not in use. This is my project work part. What I will be using, this is the part for my project that I'm mapping it into the workspace. This is a folder inside the container, and I'm calling the container here. That what you can see, this is the name of the container to be launched inside the notebook with this port. So once I run that, see, so it's going on, and so yes, the notepad is running now. So what I need to do next is, because I'm connecting remotely, that's why I'm doing all this configuration. For your own personal system, you might not need to go do this go too long this way. So yeah. So for if you are working directly on your workstation, you don't need to do this part. So what will happen is, after you have launched your container like this, so you just go to your browser. So you go to your browser, then next thing you do is what you just say localhost and this, and it will run. So this is the project part. So what I have here is my data. This is the data I told you to test, eval, train, and validation. These images, there's nothing there. It's just an image that I used for this notebook. That is what is there. It's not part of the project. So it's just what I use for this notebook. Then there's the specification file, which I told you, this is the one for training, and this is the one for retraining. So we get back here and what click on this is our notebook.